Okay, we have here another integral today. This one's from the Caltech Math Meet 2025, number 1. We have the integral from 0 to infinity, x to the 7th, e minus x squared dx. In a previous video, we did this one using the gamma function, and so we'll do it kind of a slightly alternative method. They're really similar, so I don't know if it's a full alternative method, but we are going to focus on the Laplace transform. We've got our definition right here that if we have an integral from 0 to infinity, f of x e to the minus sx. This is going to be our definition for the Laplace transform, where this function's coming from right here. What's going to come out of this is going to be a function in terms of s. Now with our problem, we're not really in the right form. We don't have an s, but also we've got x squared. So it's not going to work the way we have it, but it's also not going to be too much of a problem because we can do a u substitution. And this step is the same as what we did in the previous video. We did a substitution for u equals x squared to clean that up. Then take a derivative, du is going to be the same thing as 2x dx. So then I can take our integral and just split up the x to the 7th. I can write x to the 7th as something like 1/2 x to the 6th times 2x. And then we'll keep all this other stuff. So with what we did here, this is going to be our du, and 1/2 can come out front as a constant, and everything over here is still just x to the 7th. So we'll go ahead and substitute, bring in the 1/2 out front. We'll get the integral from 0 to infinity. The bounds don't change when you plug in infinity and 0. I think that's clear. X to the 6th, I can write that. So using this, if we have u cubed, that's going to be the same thing as x to the 6th. So this becomes a u cubed e minus u. And then everything else is going to be just du. And then I left a little space right here for this parameter that we want. We'll just kind of create this out of thin air. We'll just create an s, but we're not changing it because I'm going to define it and say that s is going to be 1. So same problem. But doing it like that, now we have something exactly in the form of our Laplace transform. Our function, now it's just going to be in terms of u, but it's just going to be this u cubed. So this whole integral, we can just write it as the Laplace transform of u cubed. And what we can do is we have a formula over here for this, an integral in this form. I have on my website a Laplace transform cheat sheet. So this is kind of one of the more simple cases, but on there I have like almost kind of any function that you would come across, like the trig functions, exponentials, unit step functions. We have formulas to calculate those Laplace transforms. So for this formula, first we're just going to have this 1/2 out front. Using this, we'll substitute back on our s, but right now we're creating a function in terms of s. So we're going to have s to the n plus 1, where the n value is going to just be this 3 here. So 3 plus 1, we'll have s to the 4th. And then in the numerator, we have gamma of n plus 1 again, so it's just gamma of 4. But the gamma function can be expressed in terms of factorials. So we can do this as n factorial or 3 factorial or just 6 for this value right here. And then we can take our s value and plug it in, because we were just kind of doing this as a placeholder because we know our s is just 1. But if s is 1, this goes away. And all we're looking at here is 6/2. And so for my final solution on it, we just get a 3. Okay, there you go. That's it for today. Thanks everyone for watching. Have a good day.